Good morning students, welcome to fourth video on problem section of system of particles and rotational motion. So in this problem we want to know what is the kinetic energy and angular momentum of the earth rotating about its own axis. The earth rotates about its own axis with a period of 1 day. We know that Earth rotates about its own axis in a period of 24 hours, which is 1 day. If the mass of the earth is 6 into 10 to the power of 24 kg and the radius is 6400 kilometer, calculate kinetic energy and angular momentum of the earth. So we want to know what is the kinetic energy and angular momentum of the earth, which is rotating about its own axis in 1 day. That is what they have given. So mass is given. Mass of the earth is 6 into 10 to the power of 24 kg. Radius of the earth is given 6400 10 to the power of 3 meter, which is nothing but 6400 kilometer. And the time period in which the earth rotates is about its own axis is given, that is 1 day. 1 day is 24 hours into 60 minutes, or 1 minute it is 60 seconds, so it is comes up to be 86400 seconds. So now we want to know what is kinetic energy and angular momentum. So we know kinetic energy formula is in case of rotational motion, K is equal to half I omega square, and we know angular momentum is L is equal to I omega. To find both kinetic energy and angular momentum, initially I want to know what is the moment of inertia of the earth rotating about its own axis. So we know that earth is assumed to be a solid sphere of radius r, which is rotating about its own axis. So we will take the moment of inertia of the earth is similar to the moment of inertia of the solid sphere. Therefore, if I is the moment of inertia of the earth, as I told that earth is assumed to be a sphere of radius r in which the axis passing through its center, then moment of inertia of a solid sphere in which the axis passing through its geometric center is 2 by 5 m r square. So this is what we know from the moment of inertia concept. Moment of inertia of a solid sphere in which the axis passing through its geometric center is I is equal to 2 by 5 m r square. So earth is assumed to be a solid sphere of radius r and whose axis of rotation is passing through its center, the center of the earth. So on substituting all these values we get moment of inertia. 2 by 5 into m is 6 into 10 to the power of 24 into 6400 10 to the power of 3 is 6400 kilometer square. So moment of inertia of the earth is I is equal to 9.83 into 10 to the power of 37. Unit of moment of inertia is kg meter square. So we got the moment of inertia of the earth, which is rotating about its own axis. So now let us calculate what is the angular velocity of the earth. With what angular velocity earth rotates about its own axis in a period of 1 day. So if omega is the angular velocity, then omega is equal to Angular velocity is angular displacement divided by total time. Angular displacement in this case is to complete one rotation is 2 pi divided by t. T is the time taken by the Earth to complete its one rotation. So which is 2 into 3.142 divided by t is, it is in terms of second, 86400. So angular velocity of the Earth is comes out to be 7.27 10 to the power of minus 5. So our omega is equal to 7.27 into 10 to the power of minus 5. Its unit is angular velocity unit rad per second. So Earth rotates about its own axis with an angular speed or angular velocity of 7.27 10 to the power of minus 5 rad per second. So now let us calculate kinetic energy. If K is the kinetic energy, of the Earth, rotating about its own axis, then because we know all parameters depends on the axis of rotation, they are going to change when the axis of rotation changes. So we have to specify axis of rotation in all the cases while doing the problems on system of particles and rotational motion. So then K is equal to half I omega square. K is equal to half I omega square, which is equal to half into I, just we got moment of inertia as 9.83 10 to the power of 37 into omega square. Omega means 7.27 10 to the power of minus 5. This is square. So this is into square of this. So we will get the kinetic energy as K is equal to 2.6 10 to the power of 29 joule. So this is the kinetic energy of the Earth rotating about its own axis. So now let us calculate angular momentum. If L is angular momentum of the Earth rotating about its own axis, then L is equal to, it is I into omega. So again now we know I is 9.83 10 to the power of 37 into omega. Omega is 7.27 10 to the power of minus 5. So finally the angular momentum is comes out to be 7.15 10 to the power of 33. The unit of angular momentum is kg meter per second. Kg meter square per second. So therefore angular momentum of the Earth rotating about its own axis is 7.15 10 to the power of 33 kg meter square per second. Kg meter square per second. So this is the angular momentum of the Earth rotating about its own axis, and K is equal to 2.6 10 to the power of 29 joules is the kinetic energy of the rotation of the earth about its own axis.